Hello and welcome to today's MidVision webcast. Today we're talking about the art of WebSphere MQ deployment automation. My name's Helen Beale, I'm the Head of Sales and Marketing here at MidVision, and today I'm joined by Rob.
Hi there, my name's Rob Vanstone. I'm the WebSphere MQ and Message Broker Architect and a Principal Consultant at MidVision, implementing our solution in our clients.
Today's webcast is 45 minutes long, and we're going to start by looking at deployment automation and the key drivers and the value proposition around it. Then Rob's going to outline the RapidDeploy architecture for you and then talk specifically about the MQ plugin. He's then going to give you a demonstration of the tool, and finally we'll talk about what to do next and the free trial that we offer. So first of all, what are the business benefits of application release automation, or otherwise known as deployment automation? Why do people buy these kind of tools in the first place? Well, what we see in the market is a kind of maturity scale where at the bottom people are doing everything manually and finding it very time-consuming, a very onerous job. The more releases and the more pressure and the more complex their infrastructure becomes, the more they start to think about ways to minimize their workload. They start writing a script or two or three, and very quickly they start writing more and more scripts, and they end up with a kind of script monster, and perhaps there's only one or two people within that organization that understand the script monster, and they become a bottleneck to what's already a very lengthy process. At this point, some of our customers and prospects have got as far as perhaps building their own tooling around their scripts. Perhaps they've built a graphical user interface, perhaps they've built some self-service capabilities or some security, some roles within the tool. Perhaps they've built some integration points into other elements in their ALM or DevOps toolchain. But all of these people are trying to solve the same problems. They're trying to get releases out to market faster. They're probably under very similar pressures in that they have businesses that are demanding more and more innovation be taken to market. So they want to make productivity gains. They need to be able to manage the cost associated with their IT infrastructure better. They need stability in their systems, and unfortunately manual and script-based processes often lead to failures and incidents and instability in environments. And also it's very difficult to audit where you are with a script and what you've done, whereas with a tool you have a record of everything that everybody's done in the tool. We can do things with some of our customers that we can spin up an environment they may have had 3.5 years ago because we've got a record of everything that they've ever had. So those are the kind of reasons that people will tool. And there are other advantages of having a vendor-managed tool over your own tool that you might have built yourself. We have a number of customers globally, and we're very a core philosophy of ours is to take advice and direction from our customer base into our product development roadmap. We're developing it all the time. It's all we do. So we're pretty sure that nobody out there is going to be able to keep up with our pace of innovation in this specific area, which is our specialty. So there's lots of benefits to be had, mainly around increasing in reducing errors, the ability to meet compliance and get to deadlines, and there's some sort of softer benefits around this as well. What we hear a lot from our customers is that they're having to work very late, or they're under enormous pressure, or they've got people shouting at them down the phone because the system's come down again and no one knows why, and no one can roll it back very quickly, and no one can identify what change caused the failure. All of those problems are things that we can solve with application release automation. We massively speed up the release process itself, so you don't have to stay late. You shouldn't be getting calls at weekends because there should be controlled change, pre-tested change, and you've got a very quick way of rolling back to a previously known working version. The other thing that we see, and this slide here is again by Hurwitz as the research analyst, this slide is really about why people ultimately choose to take the step to automate that deployment process when they've perhaps been doing things quite organically previously. And what we see in the marketplace is we do actually very rarely see a deployment automation project standing alone. They're usually part of a bigger project or triggered by another project. So we have some customers that wanted to build a PaaS or a platform as a service and thought that building that PaaS initially was going to be much quicker using an automation tool, and also recognised that managing the PaaS long term was going to be much easier once that tool was in place. We also see a lot of customers buying these tools at the point at which they're doing big middleware upgrade projects. We also see people doing re-architectures, creating DR environments, moving applications from one platform, say an AS400, to a different platform, Solaris, and seeing this as an opportunity to build their new platforms more quickly. There's lots of different reasons that people move forward, but let's look at the tool itself in a bit more detail.
Okay, so RapidDeploy is made up of a core application framework which deals with, and we'll talk about this in a little bit later, the basic activities that the tooling does. And then all of the implementation of that functionality has been put into self-contained plugins that link up with the core application framework and perform their individual tasks. So we have target plugins, cloud plugins to interact with cloud web services, toolchain plugins to interact with the other tooling you may have in your development and ops environments. So as I mentioned, in the core application framework, we have the basic activities, installing and patching. Irrespective of whatever technology we're talking about here, the core application framework will provide the interface for each of the plugins to do those jobs. Configuration management, scheduling and workflow, access, secure and role-based access to the tooling, and then providing reports or environment intelligence in the case of snapshots and configuration comparisons. And then the plugins implement a lot of this functionality in their own way. And the benefit of having the plugins gives us a lot of flexibility. If we want some new functionality, we can keep an existing plugin but create a new version of it that another customer may wish to use. And that safeguards what we've already deployed to our clients, at the same time as providing us with the ability to develop these in an agile way. So our target plugins enable us to connect to a different set of middleware applications, databases, so JBoss, Tomcat, WebLogic, MQ, which we'll talk about a bit later, Message Broker. The list is growing, and then our toolchain plugins allow us to interact with those toolings that you have in your development and operations environments. And in this next slide, I will cover that a little bit more, because we have the concept of different roles within this DevOps toolchain. So the developers typically will interact with source control systems and store their code and their configuration in source control, and then use a set of build tools to package those up into deployable artifacts. Now, RapidDeploy can interact with both of those and provide you an interface to check in and check out your code into different source control management tools, Subversion, Git, ClearCase, Rational Team Concert. It can also invoke builds through common build engines such as Hudson Jenkins, Cruise Control, Maven, and again RTC. And so the development lifecycle becomes quite encapsulated into focusing the developers into producing releases that are packaged up and can then be deployed. And moving around clockwise in this circle, we can provision the ability for developers and testers to be able to deploy that change to the lower level environments. And we're very conscious of the not trying to restrict what developers can do in a development environment, but also getting them to use the tooling in the way it's going to be used by, say, a release engineer, who would then log in and have a different set of access and be able to push things into the production environment. So the development have an aspect and a kind of appreciation for what operations are going to do when they're running with the tooling. And then operations at least doing the things that the developers have done in the pre-production environment. So this lends itself very well to a continuous delivery approach, the idea of packaging up a build, testing it in an environment that's a low-level environment, and then fixing any issues, repackaging, and go through this life cycle very quickly, having the ability to produce packages and get them out to your targets in a consistent, repeatable way very fast. Okay, so the MQ plugin. I've mentioned the core framework, which offers the interface of doing installations of the binaries and then deployment of configuration. So with the MQ plugin, we have the ability to install WebSphere MQ on distributed environments, Unix, Windows, Linux, all flavors of Unix, and then to deploy the objects to those queue managers, create queue managers, and delete and remove them as well. And then all of this intelligence comes from the package that's been built. So we source control what the configuration of a queue manager looks like and can package that up into a package that can be deployed not only to the development environment but to the QA environment and then onto the production environment. And the deployment activity will flavor that package at deploy time to meet the needs of the environment in question. And that's the idea of build once, deploy anywhere. Okay, so I'm about to show you a brief demo on some of the core capabilities of the MQ plugin coupled with the RapidDeploy framework. We're going to install MQ onto a Linux server, and then we're going to create a queue manager with some queue manager objects in there, which we will call the development queue manager. When we are happy with that queue manager, we will then clone it and build out the QA version of that queue manager, and you'll see that the process then becomes very, very similar. It doesn't matter what environment we're talking about, we are doing things in exactly the same way. And then we'll look at some of the snapshot capabilities, and this is where we can go to an environment and pull out the queue manager configuration, and then we will make some arbitrary changes to that queue manager and then do another snapshot and show you that we can detect configuration drift or even just detect changes between a queue manager over time. We will then compare two different queue managers. So a common use case is people want to know what's different in their QA environment to their development environment, or their production environment to their QA environment. So I'll demonstrate that capability as well. So without further ado, I will take control . Okay. So just to talk about our environment a little bit, I've got RapidDeploy running locally on my Windows laptop, and I have a Linux virtual machine, which is just a bare-bones Red Hat Linux, and I can access that through SSH as normal. So we will log into RapidDeploy. And this is a web application, so in this case it's running on Tomcat. It can run under other web containers, and it's a rich UI. So we have pop-up menus. You can right-click and get the same menu. Everything you'd expect from a feature-rich user interface. Now, the core of this is our resources. So we talk about projects, which is a well-used term, I understand, and then targets, where we're going to deploy to. And I'll start with the projects. Now, the project is the core of what we're going to do. What is it we're going to do on the target? And there's a little bit of admin. So in this case, I'm going to create a project to install the MQ binaries. And so we fill in various fields. Now I've just changed that to be a binary install, so we have different types of project, code deploy or binary install, and set up some of the admin aspects. Now SCM repository, this goes to our tool chain a bit. In this case I'm going to choose file system, but depending on which plugins you have, you can interact with Subversion, Rational Team Concert. This is where we're going to store our configuration. And then the artifact repository, again, this is where we're going to store our packages, and we have the concept of a build store. Now this could have been a Maven repository, and RapidDeploy would interact with Maven and select the right packages out of the Maven repository. Now this is an MQ binary install, so we'll select that and just leave the defaults. Okay, so we've created our project, and as I said, our project is the what is it we're going to do. And I'll confess, I've done a bit of preparation here already, so I have already got an orchestration I can use, and it's very simple. An orchestration is a list of the tasks we're going to perform, and in this case we're going to do a binary install, and then we're going to set this as our primary instance. So to do that, we need to configure our target. So this is our server that we're going to deploy to, and it's a Linux host. Just fill in the fields. Now, the transport plugin here is how we're going to connect to that. And I've installed an agent, which is just a very lightweight Java process running on the target that listens on a port. So we connect to that port, and we've tested that we can connect. We can save our server object. And then, especially now with MQ version 7.5, we could have multiple installations of MQ. So I need to create this particular installation, and I'm just going to use the default location for MQ in this case. So I'm going to install it in opt-MQM. I select our server and our project that we're using to perform this installation. So we have pretty much all the ingredients we need to install MQ on our target, and we have the concept of a job, and the job here is to deploy MQ to our target, which we've just set up. And already in my build store, I have different packages for MQ. So I've got the binaries for Linux, I've got a server-only package and a client-only package. In this case, I'm going to use our server-only package. And then I go through the deployment process and execute that. Now, the intelligence is in the package here. So the package is what you would download from IBM, and a list file, which indicates all of the file sets you want to deploy to your target. So we get a bit of a progress indication of our deployment. So it tells you all of the activities it's going through. It transfers a number of libraries to the target and then runs our tasks. So you can see them there at the bottom, our MQ binary install task and then our set primary installation task. At the moment it's copying the jar files over in chunks, and that's all handled by the agent, and now we're running the deployment. So the archive, the binary archive that we've copied over is being expanded out. The file sets are being interrogated, so you have a list of all the file sets we're going to install here, the RPM files, and then we go through and step by step install all the ones that were in our list file. Okay, and without much trouble, we've just installed WebSphere MQ. And now what we're going to do is we're going to create a project to create a queue manager on that. Now this is a different type of project. This is what we call a code deploy project. And that's a catch-all really for any type of configuration change on a target. So with MQ, we have pre-written tasks in that orchestration panel, which I'll show you shortly, that will create a queue manager, and then a task that will deploy MQSC to that queue manager. Again, we select our SCM repository plugin, and in this case we use the file system plugin that ships with the product. Subversion also ships directly with the product. Now everything's flexible here, so I've specified an area on the disk where I want to store my configuration, and a whole number of projects can use the same area to store configuration and use different orchestration files as required. We specify the name format of our package. It must contain the word WMQ create, for example, and it's the MQ plugin that we're using. So again, we have our product, and at the moment that's just an empty project really. What we have to do is create an environment configuration. So this is where the power of the tooling comes in. We have an empty orchestration right now, but when I create my environment, I can create from a template of pre-existing orchestrations that we ship with the product, something that will create a queue manager on the target. And we'll go through that now. Okay, so our environment definition involves a couple of logical names, environments, an application, and then something real physical, which is the server. And now we have the MQ template that we're going to fill in. And this is a form that we would fill in with all the details about the queue manager that we want to create on this particular target. And an MQ administrator will, recognize all of the fields, but there's a comprehensive set of help with every field that we have to fill in. And some of this flexibility in the structure of how we store our files and scripts, MQSC scripts that we will use, is built right into this template provision here. So we'll leave a lot of them as the defaults, the log file path, but if you had a multi-instance queue manager, for example, you could put a shared path in there. And this is where we select our specific orchestration. So we've got 3 to choose from at the time of going to press. We're going to use the create and deploy orchestration file, which will have 2 tasks in, one to create the queue manager as we've specified it here, and then a task to deploy MQSC. And again, I've already got a sample MQSC script in the structure that I've defined here, just to save time in the demo. We have to configure our server object. So this time we want to connect as the MQM user, so we're using a different agent here that's running under the MQM user in this case. But we could also have chosen SSH as our transport and specified a user that can connect over SSH. And there's quite a varied amount of flexibility there, because we could connect as a particular user that has no privileges but can run sudo, for example, to execute MQ commands. So we have our server and we have our environment configuration. Now what we need to do is create a deployment package that contains all of that. And remember, all of this is stored in our source control management system. In this case, it's on the file system, but it could have been in Subversion or RTC. So we would create a package from all of that information, and we will look at this a little bit later when we do some of our comparisons as to what's actually in this package. So again, we select what it is we want to deploy. Here we're deploying our QMGRD1 using the deployment package we just created. There are a number of options available to us here, which are beyond the scope of this demonstration, but give a lot of power and flexibility to our deployments. Okay, and everything is the same. So we have executed a job, it has progress associated with it, we can follow that progress, we get very visual indication of the success of this project. All of the jobs that we run are kept in the audit record. These can't be deleted, so we're preserving exactly what's been done on the system, and we've created our queue manager. It's running under the listener we configured, and we've deployed some queues to it. I actually set this up as default queue manager if you notice that in the template. And there is our list of queues. So very quickly we've been able to install a product, create a queue manager and apply some configuration to that queue manager. Log file sizes, locations, everything that you'd expect to create on a queue manager has now been done in a predetermined way. So what I'm going to do now is assume that we're happy with our development environment and we want to go ahead and build out our QA environment. Now ordinarily this should be on a different server. We're just going to use, for simplicity, the same server that we used for our dev queue manager. Obviously you wouldn't do this in real life. And we just change some of the names now to represent our QA environment. Now, what makes this work in different environments is the fact we have a data dictionary. So for every environment configuration, the data dictionary is a set of parameters that can change depending on what environment we're in. So in this case, what will change are things like our port numbers and anywhere where our queue manager name has been mentioned or QA has been mentioned. Anything that you'd expect to be different. So in this case, we'll change the port number so they don't clash, and the queue manager name to be Q1, still on the same server, and we'll create this environment configuration. So that is called cloning a configuration. And it doesn't matter how complex your environment is, that cloning activity will give you the opportunity to change anything that needs to be changed in terms of the dictionary. And because we've created new configuration, we will create a new deployment package. And probably very familiar with, the risk of sounding tedious, you're very familiar with what we're doing now. It's the same thing every single time. So we're trying to reduce the risks of making mistakes, the risk of error due to human involvement, not typing the same commands on the command line. All of those things are done in the same way. Okay, so we're deploying our QA environment now, and obviously this is a very compressed timeline as a lot of activity goes on, probably a large number of versions of the dev code. And if you're deploying other products as well that interact with this queue manager, such as WebSphere Message Broker, they would be in the mix and may even form part of the deployment. We can create composite deployments and daisy chain them together so that one happens after the next, or they happen in parallel. Okay, so we've got our second deployment has successfully happened, and we'll just verify that by looking for our second queue manager. And there it is. Q1 is running, and you'll see we'll display the queues for completeness just to show that it's exactly identical. And the reason why it's identical is it's used the same MQSC script. That template MQSC script, and this is a pattern we use where we say queue managers want to be the same in every environment, bar any differences that are required, like channel names, host names, port numbers. All of those can be configured to be different, but the general structure of that queue manager is identical in every environment. And this helps testing. So now we're going to do what's called a snapshot. And a snapshot in this case connects to MQ as a client, pulls out its configuration, and allows us then to do a number of things with it. One of the use cases is comparing differences. So I've had a couple of goes at doing a snapshot, and I'd made some configuration errors, and that's why I've got 2 failures there. But eventually I typed things in correctly and was able to connect to my queue manager and pull out its configuration. So what I'm going to do now is make a change to our development queue manager, and this is to simulate us doing some development work. And the change is very trivial, but I will show you that the MQSC template script will be updated. And if you remember this in the context of source control management, this would all be checked in with as part of a particular change set. Here's our template script, and you can see those tokens with @ats in are the tokenized aspects, so things like the queue manager name we've tokenized in our channel. And I'm just going to add a queue. So again, this is just to show you the capability rather than show you any expertise in MQ administration here, but I'm going to create a queue of a variable name, and this could be any object or any part of an object. And for that name, I need to add a dictionary for this environment so that we can realize that name during deployment. So our data dictionary, which you've already seen, has all of our values that could vary between queue managers. And if you had the need to put passwords in your dictionary file, we can encrypt those. We can set them as password fields so they can't be read through the UI. Standard security measures for handling sensitive data. So I've made a change to the configuration, so I'm going to create a new deployment package. Again, you're going to become very familiar with how the flow of the tool works here. I can add some comment to the package, which will be in the metadata of the package. And then we'll deploy it. Now, once we've deployed this, we will then take another snapshot of this queue manager, and our primary use case for snapshots is the ability to compare queue managers over time, so you can detect if someone's made changes and understand if they've been made outside of the tooling or through the tooling in this case where we've made a second deployment, or compare different queue managers to each other. So I spoke earlier about a common use case is people wanting to understand what's different between two environments and then maybe addressing those differences. The second use case for snapshots is to be able to go to an existing queue manager and pull its configuration and use that as a basis of the template. So the snapshot generates some MQSC, and that script can then be used to recreate that queue manager you've taken the snapshot of in another environment. For example, if you're re-platforming your MQ queue managers. So we've taken our snapshot, and we're going to compare this snapshot with our earlier one. So we have a comparison aspect to the framework, and in this case we're able to compare snapshots. You can compare any files. We can upload files to compare if you want, and you can also compare deployment packages. So if you wanted to know what's different between two deployment packages, you can do so. And as you can see on the left and on the right, we can see that we've added the dev queue, and notice that that queue has had its name changed at deploy time. Now, anything in there that we recognize as a parameter, we can exclude from the snapshot. So you notice that we already had queue manager name tokenized in that snapshot. That's so that we don't show up obvious differences between two queue managers, for example. Okay. So what I'm actually going to do now is show you, I've taken a snapshot of our QA environment, and I'm going to compare the QA environment with our dev environment. So there's our QA snapshot. Remember, we haven't deployed our change to QA at this time. And we have to provide some context so you can see either side of the differences. And you'll notice that these are different queue managers, so there are some differences that we know about. But again, anything that's obvious within the MQSC, we tokenize anyway, so you're left with the difference between those queue managers. And in Dev, we've added our new development queue, but we haven't yet done that in our QA environment. So here I'm just showing that we've tokenized some things in the snapshot that we're aware would be different, so they don't come up as false positives. So finally what we're going to do, we're happy with our development environment and we want to progress that change up into QA. So we use our idea of promotion. So we're going to promote configuration from the development environment into our QA environment. So here we can select the things we want to promote. I can expand this list to show everything. I can filter on this list. So again, the UI is a very mature user interface for being able to do the intuitive things you'd expect to do. Filter out the values you want to read. Okay. And then we'll confirm that promotion. So we just want to promote that value. Now remember, we want to actually differentiate this. So we will go into this dictionary and just make sure it's correct for QA. So here I'll filter on our variables, make my change. Okay, and now I'm going to deploy this change. Now, every time I've done a deployment so far, I've created a new package. Well, in the event that you just wanted to change some configuration, and this really applies more to, say, WebSphere Application Server, where you might want to change just the heap size, but nothing to do with the code, then we can do that by using the same deployment package, but just applying the latest configuration. So I've checked the latest configuration box, and you'll see it's ticked. And I can deploy the same package that I had before, knowing that the only thing that's going to be different is at some configuration item. Now, with MQ, that was a little bit of a cheat because we actually changed some MQSC, but what it does is it does create a new deployment package, and it's very obvious that it wasn't, that it has been changed. Okay, so you notice there that I deployed the queue, and it was used the QA definition for that queue manager. Okay, and to finish off, I will do another snapshot, which has worked, and then I'll compare this snapshot with the development environment. I'll put 5 lines as context either side, and you'll notice those 2 lines are different. They both exist, but they're different because the name of the queue has differed. And that's the end of the demo. So thank you very much for listening to the demo. I'll hand you back to Helen.
Thanks, Rob. So just before you go, Rob, perhaps you can just remind everybody what you showed there.
Yeah, okay. So what we showed there was a install of WebSphere MQ onto a clean Linux server. We then created our development queue manager and deployed change to it. And then when we were happy with our development queue manager, we cloned that configuration and created our QA queue manager. Now that workflow would obviously take a number of days, weeks, months within an organization, but if you're building out a set of environments, that cloning means that we're creating things in an identical fashion. What we then did was we took a snapshot of the development queue manager, and then we applied some change to it, and we added a queue. We gave that queue a name that could be different in every environment, and then we took another snapshot. And we compared those 2 snapshots, which are instances in time. and we were able to see that that queue had been added. Now that could have been someone adding a queue or changing a property on an ad hoc basis, so it allows to detect configuration drift. Then what we did was, once we were happy with that change, we applied it to the QA environment, and we did some more snapshotting just to show the capability of being able to snapshot between different queue managers. And I spoke briefly that the snapshot can also be used to copy the configuration from one of your existing queue managers. So if you brought in this tool and you had no automation whatsoever and wanted to bring this configuration in and template your existing queue managers, that's the mechanism by which you would do it. And that's basically what I've shown you today.
Thanks, Rob. So the next step that many of our customers like to take once they've identified that they have a requirement for this type of tool is they'd like to evaluate or trial the product. That's absolutely possible. We have a downloadable free trial, so if you are interested in getting hold of that, please do email me. You can see my email on the slide in front of you now. Thank you very much for your time, and we hope to hear from you soon. Thanks. Bye-bye.
Thank you very much. Bye-bye.